Thank you. I'm a little bit disappointed I couldn't make it in person, but I'm glad to be able to present this way. I'm going to talk a little bit about an object. So I'm going to be talking about this mechanical celestial globe from about 1820 to 1830. And it's a globe. In many ways, it's quite similar to other types of celestial globes you've seen before. You know, it has meridian rings, it has an equatorial ring, it has a stand. But I think what sets it apart, or at least what set it apart for the people who made it, is that it's also a clock. And so we'll talk a little bit about that. There's a little bit you should know. Some people have tried to write about these globes, and they mostly comment on them as just an example of how Chinese science, took things from the Jesuits, and it's been an example of, I would say, the end of kind of Jesuit exchange. But most people have not really engaged very deeply with these globes because there were only a few of them. But in the past decade, there have been a variety of them that came to light, and that they started to appear in different art catalogs. They've been starting to appear more in museums. And I think it's an opportunity to reflect a little bit about how the globes can tell us more about the way that science can both be a global project and a local project. And so I wanted to focus very briefly on the way that these globes tell us about how science was moving from the Beijing court, astronomy in the Beijing court, and going outwards into the broader sphere. And it took on a very different meaning. So to give a little bit of background, it is, I think, important to know that there were different kinds of exchanges that were going on in the 18th century that are, I think, understood as really typical examples of the global exchange in astronomical knowledge. And so the most famous, or like one of the biggest, is the example of Joseph Marie Amiot and the Manchu prince Hongwu. There's some really interesting stuff that they were participating in experiments, trying to do different apparatus, physical experiments. Um, and there were also interested Chinese users who were also interested in other kinds of discoveries, like this really new article that was written about Xu Zongyan, who was interested in learning about Uranus, and he included it in his notes about astronomy and astronomical research. But I think the most famous case of a kind of a global exchange that sort of set the stage here is the imperial star catalogs. So I gave you a picture of one of the examples that comes from these star catalogs. These were a combination of Jesuit projects in a combination with Chinese observations, and they were built around throughout the 18th century, and they also were updated at different periods in the 18th century. And they provided a lot of spherical trigonometry and tried to match a lot of star names with Chinese star formations. And it's considered like a fantastic project, or this brilliant example of trying to bring Western, new astronomy with Chinese astronomy and trying to make something new out of it. But on the other hand, you have to recognize that some of those exchanges were quite limited in their impact. So it is true that a lot of this was happening at the Beijing court, but in terms of who had access to be able to view these kinds of new projects, it actually was quite limited to people who had interactions with the Jesuits. There were other kinds of global exchanges that were going on, like in the case of clockwork. So in the case of clockwork, global processes brought a variety of interesting things. So one is that the Kangxi court was trying to make clocks, and they were trying to produce their own workshop. But I would say probably the vast majority of the clocks were also being brought through imported clocks in Canton. And so that also introduced another kind of skills and commodity exchange that was going on. But these two fields were not necessarily connected unless you want to focus on, there are some Jesuits who, of course, were brought purely for their technical expertise in this. But again, the kinds of people who had access to buy these clocks also is a really limited audience. And so in this sense, when we're trying to think about what did the global exchange mean in the late 18th century into the 19th century, the actual circulation of this kind of globalized knowledge remained a relatively limited place. However, there are some things that started to change in the early 19th century, late 18th century, early 19th century, that I feel like are an interesting transition to think about why celestial globes took on a new role. And the first is about the fact that new academies started to appear. And so these are connected actually to Kaozheng and philological research. But these new academies did start to introduce mathematics and astronomy into the curriculum. And so you had an expanding audience of people who were not necessarily the historical astronomer families who were training in Beijing, who started to get access and wanted to have more access to tools and other kinds of devices. One of the other interesting cases, which I'm not really presenting on today, but is also Napier rods. So Napier rods also started to have a wider distribution, also in vernacular prints. So we have this interesting case of a novel that also tried to popularize Napier rods as a tool for conducting computation. And basically, by the end of the 18th century and early 19th century, you start to have a more popular interest in astronomical knowledge and a new variety of people who are able to gain access to that. And that brings us then to Qi Yanhui. And so I wanted to tell you a little bit about this person. Qi Yanhui, in many ways, is quite typical of a Chinese bureaucrat who he came from Huizhou, and he eventually moved very quickly through the bureaucratic system. He passed the examinations in 1809 and he passed the highest levels. And then he was given appointments in Suzhou, or at least in the areas around Suzhou. And he basically lived there for the rest of his life. And he even changed his family registration. So he moved most of his immediate family to the area of Suzhou. Um, but we know a little bit else about him, and that he started to work on these globes around 1823. And that's partly because his secretary, Jiang Lingtai, actually, his personal papers have recently been published. And so we've been able to dig into some of his personal papers in combination with a set of other published works to get a much better sense of how these globes were actually being made. And so 1823 is really interesting. To give you some political background, just briefly, in the 1820s, the Zhejiang province and Jiangsu provinces faced some of the massive environmental disasters. So there was a heavy rainfall, massive levels of famine, there were food crises, and it led to a variety of different problems for the state on how to collect grain and produce better grain distribution. Qi Yanhui was actually one of the people involved in the new grain in this project. And so throughout the 1820s, he was actually employed by the government in helping do irrigation reform. And he also wrote essays on helping the government and encouraging the government to participate in the sea transport experiment. So a famous experiment in 1826. And he also was a part of this group who argued that basically he thought that the government, shouldn't necessarily be solving all these problems, and he encouraged local gentry to be a key part of it. What we call the elite activism movement around Suzhou. He's one of the people who was an official representative who participated and helped promote that. And I think that this is really interesting because it gives us some perspective then that the purpose behind these globes, or the entire process that these globes were being made, is actually made against this background of a political crisis. And so he specifically says when he made the globes that he made the globes in order to fix the star catalogs that were made in the 18th century. And so what he and two or three other different people did is they tried to conduct a variety of gnomon measurements as well as new star observations to fix the data from the star catalog and to republish the star catalog. So one of the examples of the new publication that they made is this work that included even the gores for being able to make new types of globes to be able to print them and make smaller versions. Now, the part that becomes interesting is that this globe that we're looking at today is actually a copper globe. And this is really interesting because it's kind of relevant to what the speaker just talked about, is that we know that actually wooden globes were probably what people were more common In 1809, one of these people, Xu Chaozhen, actually published a textbook on making clocks. And in that book, he talks about making globes. And he specifically says that he didn't like to make copper globes because copper globes were too expensive for most people. And so instead, he preferred to make the wooden globes. So two particularly, all of the examples I've been able to find are all copper globes. And he specifically says that he wanted to use copper because he thought that it was a more durable material. But clearly that references the fact that his audience is really who he's addressing here, and that the copper is a reference to elites. And we know that especially through this inscription. So what I just showed you is from the London Museum example of the celestial globe. And really the inscription, on the one hand, it's not particularly complicated. All it says basically is that this globe was made by Qi Yanhuai in 1830. But the date, which I've tried to show you in this little example here, the date is written in an extremely classical format. You know, the kinds of people who could read this, it's not just everyday Chinese people. This is a really challenging kind of text and full of ancient allusions to the, Zhou period. It's a really revealing in the sense that the audience for these kinds of globes clearly isn't, the everyday scholar. It actually is a more elite scholar. So, but I do think that in some sense, we still have to recognize that these globes were a type of popularization because they did want to expand who had access to the globe. So I brought up here an example from the pamphlet. The pamphlet doesn't exist as a, as a printed work anymore, but what have we found it is listed in the collected works actually from his son. And it concludes this pamphlet, which explains that the purpose of these globes was to make science accessible, to make astronomy accessible to lots of different people. And he specifically says that it's the clockwork technology that sets apart these globes as a popular device to make it so simple that all you have to do is look at the globe and you simply know the time. And that's great. He says, even your wife and children, they can know the answer. They can, figure out the time and they can figure out celestial globes. So the thing that I kind of wanted to conclude in talking about Qi is that he's trying to use clockwork technology as a way to make astronomy go beyond the court and to recirculate it among an urban elite audience. And in this sense, of course, it's a limited audience, but it helps us understand the broader change that's going on in this period. Now, I wanted to highlight for you that we know a little bit more about how this globe actually fit into people's lives, what people thought about it. I've been able to find about 4 very specific people who wrote some kind of review or some kind of comment about these specific globes. And of course, you can guess that they represent the audience that he was reaching. These are from elite merchant class people and also art connoisseurs. And some of those art connoisseurs are also really high-ranked bureaucratic officials. And it connects to this kind of world where astronomical knowledge, I think, for these people is a part of their self-fashioning. Just kind of like the way the Qianlong Emperor was starting to collect these instruments as a way to show his erudition and his refined culture. We also see that these merchants, I think, are doing a very similar type of collecting. They're trying to display that kind of knowledge. But I think what's really particular is that there is a political claim that's going on here, that they're also arguing this kind of local gentry and local elites have some say and should be able to say something about the government. That becomes even more revealing when you look at what it is they thought about these devices in terms of global devices. So the context that all of these people talk about the Qi's new celestial globes is that they talk about them actually as clocks, not as globes. And as clocks, they say that, European imports, those remain very important. And so they say, European imports, those are still really good quality clocks. But this clock actually gives us an example of how Chinese artisans in some way are taking that technology and no longer have to rely on imports as a way to supply clocks. And another thing that they say is that they argue that this is also about historical tradition. So in one case, a guy named Liang Zhangju, a kind of art connoisseur and also reformer, he particularly argues that these devices, he claims and believes that they are, better than anything that even the West could produce. And he was aware that astronomical devices were also being produced here. And he links it with the Song Dynasty. And he basically says, these devices are recapturing the heritage from the Song Dynasty and the past. just to kind of conclude, I wanted to give you some, other thoughts about it. There are other types of reviews. So we know a little bit about missionaries. Missionary experiences also encountered these globes. And it's actually missionary experiences that kind of determined how we as historians have approached it all of this time. Missionaries tended to, when they saw these globes, thought that they were examples of the failure of the Jesuits, that they were a perfect example of why astronomical knowledge was not updated enough, why it didn't follow, good enough mathematics. And they also suggested that, it was an example of static change. But I hope what I tried to show you is that, at least for the people who were making these globes and the people who were using them, they definitely did not view it this way. In fact, they understood the globe much more as a part of China's position in a globalizing world. And I think that's really, really interesting when we think about the fact that this is, 1820s, 1830s, and into the 1840s, a period of confrontation. For instance, one person who's actually quite influential in the history of these globes is Lin Zexu. He previously was the commissioner, or, the provincial officer in Jiangsu province when Yanhuai was actually making these globes. And so he himself saw them, and he saw other devices, because there are even more devices that are also being made. And he argues in a variety of essays that these devices, should be used and popularized and made present to people. And so in this sense, it's a precursor to Lin Zexu's arguments and self-strengthening ideas that come in the 1840s. It's also true about another individual who we know about. Feng Guifeng also tried to make arguments that the kind of uh, self-strengthening that he's going to advocate is also connected to astronomical knowledge. And he also responded to these kinds of Suzhou maps and kinds of globes. So Feng Guifeng in particular criticized the imperial catalog. The imperial catalog also responded to these kinds of scholars in the 1830s. So in the 1840s, the capital court tried to produce a new catalog of star catalogs. But it was argued by Feng Guifeng and some others that they had made too many data mistakes, and it was kind of a failure of their ability with mathematics. And so you see this kind of conversation going on here between different types of groups of how they are advocating to use this kind of knowledge and to transform it. So I just hope that these kind of globes can help you see a really fun global story from a really simple object. And they kind of remind me of a way that we can think about global circulation, and not necessarily through the lens of, having to talk about Jesuits or having to talk about Protestant missionaries, but start to appreciate how Chinese artisans and instrument makers were also trying to make an identity around these objects too. So thank you.
Thank you so much for that talk. We have about 5 minutes for questions, and I see someone on Zoom. We can start. Oh, those are our questions.
Yes. This is a quick question. Thank you so much for a really fascinating talk. And so where these things happened just before the Opium War in 1839, and then the one who gave this comment is Lin Zexu, who was being involved in the Opium War. And so I just wonder when he were interested in this and talked about this before or after Opium War. And really, I think it's kind of transitional period, and it's really interesting to see this situate this in the broader historical situation.
So in terms of we know that Lin Zexu, he wrote one of his first essays in I think it's 1835. So he responded particularly to the new agricultural implements. So Qi Yanhui also sponsored the making of Archimedean screws, and it's connected to the clockwork technology. And Lin Zexu wrote an essay in support of that. And then he also wrote some things in the 1840s. And I kind of skipped over it, but the people in Guangzhou were super interested actually in these celestial globes. And so there are at least two other people, Zheng Fuguang also, and Zhou Boyi also started to make new celestial globes in Guangzhou. And even some of that tradition, I think, has continued into like 1860s and the 1880s. And I have found this fascinating example of even contemporary people around 1890s into the present. Some of the almanac making families also still use this tradition of globes. So there's kind of this ongoing relationship here. And I think where it becomes, after the 1840s, a little bit more associated with traditional astrology, and they become more a tool for astrology than understood as Westernization. So that might be one of the interesting things, and that's something I'm trying to explore in my dissertation.
Is there somebody from Zoom?
There's someone, but if you want.
Okay, I'll ask something quickly. So thank you. This is super interesting as a fellow globe historian. I wondered, are there ever any terrestrial globes involved with this, or are those just completely different instruments?
I've been trying to find terrestrial globes, and I have found the examples of certain manufacturing of terrestrial globes. I have been able to, because let's say the larger vision here is about instrument makers, and I'm trying to find Chinese instrument makers. So I have found a set of Chinese instrument makers who are said to have made terrestrial globes. However, I have not found any physical examples of them. So I don't really have good physical copies of them, with the exception of Su Chaozhun. He also created a terrestrial globe, and we have his gores. And then there is an example of, like with the Feng Guifan story, there is an 1860s story about terrestrial globes where some Buddhist monk reformers also start to build terrestrial globes. And so those are the physical globes that we have, and some of the gores. And I'm not sure that they're related to this same, they're not in the same place, but they are from a similar place. They're from Nanjing, actually, instead of Suzhou. So there is a story there about terrestrial globes, but it's a little bit harder to find the material evidence for it, that's all.
And Marta Hansen on Zoom.
Yeah, just a wonderful presentation, very interesting work. I think it's going to be an exciting dissertation. So I'm so glad I could participate in this way, since I couldn't come in person. But I had just 2 points. One is, I like I never thought of, I think this is new, and I'd like you to let us know if it is new, that the astronomical knowledge was, and these arguments with Lin Zexu and Feng, et cetera, coming out of that, these dissatisfaction with the star catalogs, was part of the self-strengthening that we think of as something that's, much more political, et cetera. So that's one I just want to know, if that's really a new modifying of that political history. But the second thing is the material circulation of these things, because you said that the copper ones, I'd like you to say something more about beyond the one that you used in the British Library, where they ended up, how they got there. Yeah.
Yeah, no, I told the story to focus on the story, but the story of the physical globes, I have had a lot of challenge of trying to figure out the physical circulation in China, but I've been able to find, I would say, one story, which is that, like I said, Lin Zexu, along with another guy named Liu Yan, I think, that they are collaborators in the new cartography project. So in the 1830s, there is a new map that was built for the state, and the map makers are friends with Yanhuai and the other guy, Zhang Zuonan, and so they're interested in latitude and using new latitude and longitude, and that's kind of the story about the globe. And so they specifically go to Guangzhou, and so that's the story of Guangzhou. Is I know that it's either Lin Zexu is the person who brought it, or it is these people, because they also started to commission, like I said, these local globes in Guangzhou. And so I know that that's the history there. From the history onward as to where they came into other places, the story only gets picked up in 1890. But basically from 1850 to 1890, I've had difficulty figuring out where are these globes, other than the biographies. I've been using biographies as a way to track who is helping whom. And in that case, in 1890, they start to be purchased on the art market. And so the case of the globe, there are two globes in the UK. I got to play with the one, or the other one is behind a screen. And that one behind the screen was the one purchased in 1890 for the clockmakers, watchmakers and clockmakers collection. And they collected it in 1890, and some of the others then were purchased. So one of the recent ones on the art market was purchased by a Swedish diplomat who was in Beijing. And that's also why we know that some of the globes are now in Beijing, or at least one of the examples is in the Beijing National Museum, but it probably is the loan from the Anhui Museum. And so there's kind of a question here. So then how did it get to the Anhui Provincial Museum when they actually are made in Suzhou? They're not made in Anhui province, but Qi himself, comes from Anhui province. So, and I know that he had family connections, and I know that Anhui has become one of the focuses of my dissertation, that clearly there is a specialized group of people who are interested in mathematical instruments of different types. So I'm still trying to unpack more of the literal circulation and material objects, but that's the best that I can say sort of now.
Thank you so much. I think that's all we have time for. And for that talk, hopefully at the end we can pick up some more questions. I now invite Thomás Haddad of the University of Sao Paulo to present on negotiating astral knowledges in South America. And Thomás, the floor is yours.
Okay, so can you see my slides?
Perfect.
Yes.
Okay, good. So good morning, everyone. Thanks for coming, and of course, many thanks to all the organizers of this conference. I'm very happy for being able to follow most of the sessions from a distance. I'm here in Brazil right now. Well, you can see there the title of my talk. It may feel as a kind of jest, but it's not. It's very sincere. I wanna share with you 3 case studies on what I'm calling the negotiation of astral knowledges in South America in 3 different moments. And above all, I would like to invite all of us to reflect a little bit about what are we doing when we approach the history of science through case studies. What are their power and limitations? So you're gonna see that there are gaps and loose ends in my arguments, in my 3 case studies. I'm not gonna be able to give you all details, of course, especially the narrative dimension is gonna be quite secondary. More on that later. What are the possible effects of the absence of this narrative dimension? But anyway, I hope through the case study of myself, what am I able to make of 3 case studies, we can reflect about this kind of approach. So just to set the scene, as usual, we have a world map here, and well, first of all, there is this man, Spanish-born Jesuit, who crosses the Atlantic, ends up in Juli, a city on the shores of Lake Titicaca in the Andes. He goes back and forth between Juli and Lima, the seat of the Viceroyalty of Peru. He learns Aymara and Quechua, 2 very important indigenous languages of the region of the Andes. He exchanges a lot of information with people in Rome, with other Jesuits. He received information from sailors who've been to the Straits of Magellan, to Tierra del Fuego. He moves to Mexico, bring about 20 years, he is writing about everything he sees, he learns, he listens. He then goes back to Spain and publishes a very important book in Seville in 1590. Then another man, a few years later, comes from Italy and ends up in Huli, again, the same city on the shores of the Lake Titicaca. He is also a Jesuit. He learns Aymara, especially Lupaca Aymara, and he writes a book on this language. This book, well, he goes to Lima first, sorry, then he goes to Huli. This book is used by other missionaries in the Andes, and it's not even close to the success of the first man's book. Then there is a third man, also a Jesuit. He was born in Santa Fe, present-day Argentina. He moves around the region. He spends all his life as a missionary in what was to become the largest Jesuit mission in history in present-day Paraguay. He writes a book as well. He sends the manuscript to Lisbon. The book is published in Lisbon, goes back to South America. Well, this is a very usual scheme of presenting things when we are thinking about circulation. All those lines and people going from one place to another. Although I'm doing the same here, I would like to tell you that I'm not entirely satisfied with this way of doing things. I think lines on the map, they really fail to capture a lot of important things. They fail to capture density of the interactions these actors establish in each point of their movement. Those lines fail to capture time spent in a particular place, in a journey. They fail to capture what I'm calling here a few interrogations. What are, in the end, the scales of our analysis, the range of movement of actors, of objects, of ideas, the regimes of circulation of objects, actors, ideas, and of whatever else is it that circulates. So I'm a little bit worried of this excessively literal geographic metaphor many times we employ to talk about circulation. So I would like to have those problems on the back of my mind when I develop a little bit more in a little bit more detail the three cases. I also need to interrogate the meaning. This is already in my title, the meaning of astral knowledge. Why am I not using this astronomy? Wouldn't it be easier to use astronomy and that's it? And what's the meaning of negotiation? Who is negotiating with whom and what is being negotiated? So astral knowledge for me, well, it's a conscious choice not to use astronomy, not because astronomy is something to be reserved for what Europeans do. It's just because I think astronomy triggers a lot of very present day connotations that I think we should avoid. Also when thinking about what European actors do. And well, negotiation. We are talking about missionary enterprises in South America, post-conquest, post-invasion. We are talking about the relationships established between indigenous peoples, several different ethnic groups and missionaries, in my case, Jesuits, but not all of them European. There is one of them, the third case study I'm gonna present to you now, who is Creole, the guy who was born in Santa Fe, present-day Argentina. And finally, perhaps the main interrogation and the one I have the least certainty about is this: what is the epistemic value of case studies? So let's move on to them, to the three case studies. The first one I'm calling idea, and it's based on José de Acosta's Historia Natural y Moral de las Indias, one of the most famous and well-known and studied books produced in the 16th century Jesuit missions to America, and his relationship to the indigenous peoples of the Americas, not to a specific ethnic group, but basically to all of the Native Americans. This is the red case. Here we have the book. This is the first edition published in Seville in 1590. The natural and moral history of the Indies. And we usually forget this very important subtitle here. And the first thing he mentions here is that he's going to deal with the notable things of the skies. This is a cosmographic book. I think it's only fair to say that this is not, or not just as usually considered, an ethnographic book or a blueprint for the spiritual conquest of indigenous peoples in the Americas. It's also a book that gained a life of its own, or a text that gained a life of its own. You have countless modern editions like this one. Just took this picture in a bookstore somewhere. You have annotated digital editions. Basically, the book has been so canonized, I'm saying here, that I think it lives on as a text, not as a book, as the material object. It's become incorporeal. It's an idea. This is why I called it the first case study, idea. But not only it is an idea, it bears an idea of what are the indigenous peoples of the Americas, the indigenous other of European knowledge. It's a book that operates on the level of representations. It creates a representation of the other, or perhaps of how otherness was produced in the discourse. And it's an integral part of the creation of this idea of the other, the American other. Astronologists are an integral part of this. The book spends a lot of time talking about, well, classical cosmography, situating the Americas in the received scheme by Acosta, but also commenting on local ways of knowing the skies. And usually in a very positive manner. He talks about this local forms of astro-knowledge. At the same time, he says that idolatry has destroyed everything that was good, was probably once good about all those indigenous peoples. Of course, José de Acosta didn't learn everything he says about the astronologies of several indigenous peoples of the Americas just by observing. He learned this by talking to people, by being taught about this. And in this, he is very far from unique. We have a lot of other examples of this kind of, some would say collaboration, some would say information exchange processes. I'm not very sure what we are supposed to say here, but just a couple of examples. This is a very important production from Central Mexico. This Franciscan friar, Bernardino de Sahagún, he really spent like 30 years with a lot of unnamed elders and artists, and probably common people from the Nahua group writing this codex, and there is a lot of astro knowledge here. This is a kind of common ground, a way of understanding each other. This is another example, Juan de Tovar, also in central Mexico, and also dedicates a lot of space to what the Nahua people think about the sky, how they count time, and things like this. My second example, or case study, I'm calling it Word. It's about a book by this Italian Jesuit, Bertonio. This is a grammar book. It's the blue thing I showed in the beginning. The book is very worn out. It's a book that all the extant copies are like this. They have been really used. They were printed in Huli on the shores of the Titicaca, and it's a book about words. Of course, it's a grammar, it's a phrase book. At the same time, it's a book that contains words and phrases in the language Lupac Aymara that signify celestial objects and how people relate to them. I find it really striking. Like in this page, we have phrases in Aymara and then in Spanish, teaching a missionary how to ask his interlocutors about their impressions of the sky. We have things here like, do you think the comet that's being spotted is a bad omen? Do you think there are more stars than we can count? And this is something to be carried across the Andes in the interactions. I would say that inquiring about people's beliefs concerning the skies and being able to speak to them and with them about this, about the stars, this was essential to enable the kind of communication that those missionaries wanted to establish with indigenous peoples. And again, this is far from an isolated example. I have, for instance, this book, dictionary on the Guarani language. We have a lot of things here mentioning the moon, not only the word, its definition, but whole phrases about the moon. Or this is a Maya language, Cachiquel. We have a lot of astronomical things here as well. My third case study, I'm calling it Inscription. It's based on this book by the Jesuit Buenaventura Suarez and his interactions with this specific indigenous person, Juan Sixto Mbiti. And this is the thing in here. The book is this one. As I told you, it was written in the Jesuit mission of Paraguay. It was published in Lisbon. You have it here. It's a very usual astronomical ephemerides book, although it contains a very interesting table like this, which effectively makes a very small village in present-day Paraguay the center of the world, the reference for calculating longitudes. But the most important thing here is that there is a specific copy of this book that bears material inscriptions of immense importance. I want to show them to you. This copy belonged to Buenaventura Suarez himself. It was corrected by him. But then at some point, the copy passed into the hands of this man, this indigenous man, this Guarani official. He was a lieutenant. His name was Juan Sixto Mbiti, and he wrote, he inscribed the book with a signature. Teniente Juan Sixto Mbiti Kwatiakobai. Lieutenant Juan Sixto Mbiti wrote this. He took possession of the book. I find this really striking and unsettling to a lot of prejudices we might have. And of course, besides carrying or bearing an inscription, this specific copy, it is itself an inscription within the colonial archive. And it unsettles a lot of things. I have no reason to believe Juan Sixto Mbiti couldn't or didn't use this book. And this makes me think about our usual categories of European knowledge, indigenous knowledge. What's this? This is, whose knowledge is this? In my opinion, this is as Mbiti's knowledge as it is Buenaventura Suarez knowledge. And I think it's very difficult to draw a line here and to look for some kind of pristine Guarani knowledge versus some kind of pristine European knowledge that's being imposed or replacing or whatever. This act of possession, I think it's very powerful. And this is the point where I stop and just invite us to think about, what do we learn by accumulating case studies, as I just did? Can we generalize somehow, or are we bound to just tell interesting stories with much more detail than I could? And this is the business of what I could say the global history of science, or history of science as we do it right now. So this is the kind of reflection that I think we can productively try to have together about our methods and our approaches. So thank you.
Thomás, Gordon McCood here. Just look at your email in the next short while. We're inviting you to a session later, so have a look. That's not a question.
Okay, I'll do it, Gordon.
Hello, I'm Luis Campos. I ran across Jose de Acosta's work a couple of years ago, and I was struck by the very first line of it, which is something like, "Is there even a heaven over the new parts of the earth?" Which is a wonderful provocation that I was like, what does it even mean to say something that way? I must be missing something quite significant about what the context was. It led me down an interesting path, but I had come to Acosta because of a footnote in Kepler's Somnium, and he says that he was inspired to write his science fiction story about people on the moon after having read Acosta's work. And so to learn from you now today that it's the engagement with the indigenous astral knowledge that Acosta is really highlighting in that work, kind of puts, for me, an interest in teaching my students about Kepler into a new light as I try to teach them about global circulations of knowledge. So thank you.
Okay. No, thank you. And I'll just comment briefly. I think there are two lines that run in parallel throughout Acosta's text. The first one is he is completely shocked by what he sees as the empire of idolatry, the empire of the devil, all over the new world. But at the same time, he is very explicit when he says that indigenous peoples are in no way lacking the abilities to think about natural phenomena, and especially astral phenomena. And they were able to develop very sophisticated calendars and time reckoning systems and things like this. And so I think in the end, he tries to reconcile those two things. What happened that turned such a sophisticated people into idolaters and devil worshippers. This for me is the tone of Hizbah. Thank you.
What was the name of the second case again, the individual there?
The second one is a book by this man Ludovico Bertonio, and it's Thesaurus of the Aymara language. I can try and just if you need to. It's oops. It's this, the second one.
Thank you. Great. Thank you so much, Thomás. I think we should move to our last and final speaker, Sajjad Nikfahm-Khubravan, who's presenting on translation and mistranslation, the case of Ptolemy's planetary hypotheses in Islamic astronomy.
Hello, everyone. Thank you very much for attending this session. A special thanks to organizers of this great event, and it's my pleasure to be here. As you have seen, my title of my talk today is Translation and Mistranslation. I thought this is something that can fit with the general theme of the conference. When we understand, what does translation mean? Translating one text from one language to another. But I thought to comment on mistranslation before that I start my talk. In translating every single text, even in modern days, always there is a risk of misrepresentation of ideas discussed in the original text. So that can happen directly in the translation, the product of the translation process, or the text that derive later from that translation. So my examples today are both from the actual translation of a Greek text translated into Arabic, and how later scholars interpreted ideas in that text. So the beginning of the Islamic scientific tradition is usually marked in the 8th century, characterized by an extensive translation movement through which virtually all available scholarly works written in Sanskrit, Middle Persian, and Greek were translated into Arabic. This translation movement stands as one of the greatest achievements in human history. It was an impressive scholarly accomplishment, not only because of the vast array of scientific works translated, but also because it led to the establishment of a linguistic and scientific tradition capable of assimilating the immense scientific corpus transmitted from other cultures. The process of this translation movement, however, was not as simple as it might seem. Selecting the proper text, acquiring good manuscript copies of that work, finding a skillful translator, and adopting proper scientific terminology are only a few examples of the kinds of challenges that shaped this process and which are not immediately apparent when looking at the final translation products. Sometimes we just look at the products, the translated text, and it seems that it's a translation, but there are different layers of complexity involved in the production of that text. Today I will talk about one particular text that shows some of the challenges that were involved in translating ancient Greek texts into Arabic. Ptolemy's Planetary Hypotheses is a very important text whose influence on medieval astronomy sometimes has been overlooked. While only the first section of the first part of the Greek text of Ptolemy's Planetary Hypothesis has reached us, the extant Arabic translation contains its full text. So somehow this is the only source that we can, drive Ptolemy's ideas discussing this book. Considering the time that we have, I'm going to discuss 2 points. One is a philological point about one passage in the Arabic translation of Ptolemy's planetary hypothesis. The second point is about a misinterpretation of Ptolemy's ideas from the planetary hypothesis by a major scholar who contributed to the Arabic translation of many Greek works. Just as a brief introduction, I should say that Ptolemy was one of the most influential astronomers of all time. His major astronomical work, the Almagest, was translated into Arabic several times. In addition to this, the Arabic translations of the Almagest were revised and reworked several times through this process. Through this process, the text of the Almagest was polished and established and was accessible widely in different versions at an earlier stage in the Greco-Arabic translation movement.
Sorry, just a second, the people online are not able to see for some reason. Oh,
Are you seeing?
yeah, that's fine.
Okay,
It's good.
great, thank you. The planetary hypothesis is an astronomical work that Ptolemy wrote after his Almagest. While the planetary hypothesis was translated into Arabic and was used widely in Islamic astronomy, its reception has not been studied much. One can argue that this was due to a lack of evidence in historical sources. But as we will discuss today, there are sources that can shed light on the reception of Ptolemy's planetary hypothesis in Islamic astronomy. Today, I will discuss also another work by Ptolemy that is called On the Criterion and Hegemony. It is one of the minor works by Ptolemy that was written before the other two. I believe that this work was also translated into Arabic, however, no manuscript copy of it has been discovered. This work of Ptolemy helps us to understand some of the ideas discussed in his planetary hypothesis. The dynamics of heavenly motions was a key question for philosophers and astronomers of ancient and medieval times. When discussing the dynamics of heavenly motions, we refer to the causes that generate and sustain celestial motions. Ancient astronomers could study the kinematic of heavenly motions without addressing their dynamics, but in a certain context, they explore both aspects. For example, in the Almagest, Ptolemy focuses mainly on establishing geometrical models to explain the motions of the planets. But in the planetary hypothesis, he goes beyond this and discusses the dynamics of these motions and constructs a physical system that produces these motions. Thus, the dynamics of heavenly motions is the main theme of the planetary hypothesis. Ptolemy's view on this topic must be understood in light of Platonic Aristotelian tradition. In his metaphysics, Aristotle posits that each planet requires a number of spheres, with the motion of each sphere being transmitted to the next. The mover of each sphere, according to Aristotle, is an unmoved mover external to the sphere's body. Ptolemy, building on Platonic Aristotelian tradition, assumes that the heavenly motions are akin to the motions we observe in animals. This represents a major departure from Aristotelian doctrine. By drawing an analogy between heavenly bodies and living animals, Ptolemy takes a different approach compared to Aristotle. Like Aristotle, Ptolemy posits that a combination of spherical bodies is required to describe the motions of sun, moon, and planets. The main features of his hypothesis is that this combination of a sphere forms a heavenly living animal. Ptolemy was not the first person who suggests such a story. It existed even before the time of Aristotle. But the way that Ptolemy introduced his theory is unique. Ptolemy believed that the planets are ensouled and the source of the power that governs the individual sphere of each of them. The planet is nested in the innermost sphere, such as an epicycle, and through contact, the moving power is transmitted from the innermost sphere to the outermost sphere of each planet. This stands in clear contrast to Aristotle's doctrine, which asserts that the mover of heavenly bodies must not be inside the bodies. This is the key point in Aristotle's theory. He talks a lot about this in Metaphysics Lambda to establish that there's no way that we can assume the mover of heavenly bodies is inside the orbs or whatever form those heavenly bodies they have. Instead, they are unmoved mover being outside physical universe. Ptolemy's reform thus makes the heavenly bodies akin to animals in sublunar world, which according to Aristotle have their movers inside themselves. Again, Aristotle has a work on the motion of animal, and he established that movers of animals in sublunar world should be inside themselves. It can be like celestial bodies outside. Having discussed this preliminaries, let's now turn to a passage in Arabic version of Planetary. The original Greek text of this passage is lost, and it is only available through the Arabic translation. There is also a Hebrew translation of Ptolemy's work made based on the Arabic translation. I'm here using the Arabic text. The Hebrew translation is a very faithful translation of the Arabic text, so it follows basically the same structure that we see in the Arabic text. In this passage, Ptolemy emphasizes that the celestial ethereal bodies are unchangeable, eternal, and homogeneous with the power of the stars carried by them. The light of the stars passes through the ethereal bodies without being hindered. He says this happens in the same way that their powers and lives pass through things among us that are similar to them. I should mention that in Al-Majaz, Ptolemy also talks about this kind of topics, especially in Al-Majaz 13, after his discussion of a general discussion of his planetary latitude theory. But there he doesn't talk about sublunar world and how they are, the celestial realm is similar to sublunar world. In contrast, he emphasized that these two worlds are very different, so we shouldn't assume that what we conceive here in sublunar world is the same as what's happening in the heavens. But here in planetary hypothesis, he's doing something else. He's making the analogy between sublunar world and the heavens. This suggests a similarity between celestial bodies and certain objects in sublunar world, which is a serious departure from Aristotelian physics. While Aristotle separates the sublunar world from the heavens, Ptolemy suggests that there are things in sublunar world similar to the ethereal worlds. Ptolemy mentioned two sublunar things as examples of those similar to heavenly bodies. In the Arabic text, we find basar, the green one, and which means basically vision, and fahm, the red one, meaning perception. However, neither vision nor perception are physical objects comparable to celestial bodies. The structure of the sentence, suggesting that, he's comparing two objects, two physical bodies. But in one case, he's talking about celestial bodies, but in the second, he's talking about perception and vision. So neither vision nor perception are physical objects comparable to celestial bodies. Before considering possible explanation for this passage, let's have a look at another work by Ptolemy on the criterion and hegemonic. In the final part of this early work, Ptolemy discusses the human soul and body, their faculties, and their relationships. Through this discussion, he defines the hierarchical relationship between different bodily organs. But what is important for our discussion today is that he posits that the human soul is composed of air, fire, and surprisingly ether. Essentially saying that the fifth Aristotelian element from which all heavens are constructed exists in sublunar world and is part of the compound matter that makes the human soul. Returning to our passage in the Arabic version of Ptolemy's planetary hypothesis, we see that Ptolemy mentions vision and perception as two things similar to heavenly bodies. But since vision and perception are not objects to be similar to celestial bodies, one might ask, is something missing from this passage, or did the translator mistranslate Ptolemy's terms? Interestingly, vision and perception are are classical faculties of the soul. Can we assume that Ptolemy had the human soul in mind when writing this passage? Again, in Aristotelian psychology and in later Aristotelian tradition, soul has different faculties, and two of the major of which are vision and perception have been discussed even by Ptolemy in his criterion. So this brings to mind the idea that maybe he is referring to soul and its faculties when he's talking in this particular passage in Planetary. In the passage of the planetary hypothesis, if we replace vision and perception with human soul, it would align with his philosophical doctrine. Alternatively, one can suggest a different interpretation. In an ancient theory of vision held by many scholars, including Euclid and Ptolemy, visual rays were responsible for human vision. In this theory, visual rays emanate from the eyes and touch visible objects. Through this procedure, we are able to see objects. Ptolemy might be referring to visual rays and vision process in this passage. As you may know, Ptolemy had a work on optics that unfortunately has not reached us in the original Greek version. It was translated into Arabic. Again, unfortunately, the Arabic version has not reached us, but the Arabic text was translated into Latin. Again, unfortunately, the original translation has not reached us, but there is a kind of rework of Ptolemy's work in Latin that unfortunately doesn't have the first book of optics, where he actually talks about his theory of vision. So we don't know if it makes sense if we assume that when he was talking about visual rays, like soul, he was taking them to be compound matter made of ether as well. But we are left with no answer to this question. We just need to leave it as an open question. This was only one example in Arabic version of Ptolemy's planetary hypothesis, where the translation raises questions about what Ptolemy intended to say. Although this might look like a minor philological discussion, it is important for how we will evaluate Ptolemy's general physical theory. we don't have any other text by Ptolemy in which he discussed this topic. So the only source that we have is Planetary Hypotheses and this Arabic version. So we should, that's something that I'm doing for years and going one sentence by sentence, trying to figure out what's happening and reconcile Ptolemy's physical theory. I should mention that, people were using this text before me. I'm not the first person I'm looking at this, but the deficiency of thorough study of this text, affected the quality of the studies that has been conducted on Ptolemy's work. For the final part of my discussion, I will focus on a misinterpretation of Ptolemy's models from planetary hypothesis. This misinterpretation at first sight might look like a minor negligible error again, but I argue that this is important evidence for determining the story of reception of Ptolemy's planetary hypothesis in Islamic astronomy. You can see my general approach, as you will know, errors are very important in history of science, sometimes more important than correct things that we find in historical sources. So it gives us insight about what's happening in this text. So since I'm beyond time, that I'm just going to skip a few parts of my discussion. So basically, what we are seeing here is Ptolemy's model for upper planets. What I want to emphasize is this little circle here, which is epicycle moving from an eccentric. So in order to explain the longitudinal motion of planets, this model works very well, and Ptolemy's system was very successful in predicting the position of planets. But there were problems in his latitude theory. In order to explain the latitudinal motion of planets, he assumed that epicycles of upper planets oscillate. If you assume that point C is the apogee of the epicycle, it comes sometimes to the south of the eccentric. AB shows the plane of the eccentric, and it returns to point C again. This oscillation was a major historical problem, even for Ptolemy himself, who eventually revised his theory in planetary hypothesis, and instead of an oscillating epicycle, assumed that the epicycle has a fixed inclination, but is placed inside a sphere, and so this combination of a sphere forms an Euclidean couple, which was used by Eudoxus himself in his astronomical system, and then by Aristotle in his metaphysics, and through that was probably handed to Ptolemy, who eventually used this form of the Eudoxian couple. So he basically nested his epicycle inside a Eudoxian couple that we see here. Then, because the epicycle and the inner sphere in the couple has the same axis and center, so he combined these two together. So beta shows the motion of epicycle from Almagest, and the alpha shows the motion of eccentric. So this is my important parameter that I'm going to discuss in the next slide. So the outer sphere moves with the motion alpha, but the inner sphere moves with the motion alpha plus beta. So Sajjad was one of the major translator and astronomer and natural philosopher of early Islamic period. He contributed to many into translation of many works from Greek into Arabic. He has a very short text in 2 folios with this title that you see here on the orbs, their disposition, the number of their motions, and the extent of their travels. In this work, he used the Ptolemy's planetary hypothesis, but he doesn't mention that. He just, we were able to determine that by the ideas discussed in the text. But what he does in this text is that he is presenting Ptolemy's epicyclic system in this text, but with some problems. So as I showed in the previous slide, we saw that the outer sphere here moves with the speed of alpha, the eccentric, but the inner sphere moves with the alpha plus beta. But the way that Khubravan introduced this model, he just talks about the motion of the inner sphere as being beta, and he took that that motion from Ptolemy's Almagest. So basically, what he does, he mixes the Almagest theory with the planetary hypothesis. So this mistakes or misinterpretation of Ptolemy's work gives us ideas about when exactly Ptolemy's work was translated into Arabic and how it was received. The case of Ptolemy's planetary hypothesis, its Arabic translation and the text in which it was used is only one example. In the case of every single text translated during the Greco-Arabic translation movement, it is possible that we encounter these kind of challenges. It is important to keep in mind that editing and recovering these Arabic translations in a comparative study is necessary to avoid misinterpretation of topics discussed in this text. Thank you very much.
I know we're past time. If anyone has questions and comments today, please feel free to do so. Otherwise,
That was superb, by the way. Thank you. It's fascinating. The theme of the conference perfectly.
yes. Just a quick question. So, to what extent are translations expected in the medieval period faithful, or were the translators involved in, given that they were creating new language for these
I'm gonna end the meeting.
It's not easy to answer this question, but I just can mention one example. If you look at Khubravan's revision of an original translation of Ptolemy's Almagest, we can have a sense how perfect a translation